This project presents a workflow for digitizing real-world indoor environments and enabling interaction in virtual reality. Initially, the room is scanned using LiDAR-enabled device or depth sensors, generating a raw three-dimensional mesh of the environment. This mesh represents the geometric structure of walls, floor, and objects directly, without an intermediate point cloud. Texture data is then projected onto the mesh, producing a photorealistic representation of the scanned environment. The process preserves the spatial and visual fidelity of the original scene, enabling realistic rendering in real time. The raw mesh is subsequently refined through a series of cleaning operations. These include outlier removal, hole filling, surface smoothing, normal correction, and polygon decimation. These steps optimize the mesh for visualization and interaction while maintaining geometric accuracy. Finally, the processed mesh is imported into a virtual reality environment. Users can navigate, inspect, and interact with the reconstructed space, enabling application in design evaluation, simulation, and immersive experience development. This workflow demonstrates a systematic approach to converting physical indoor space into high-fidelity interactive virtual environment, directly from mesh acquisition to VR deployment.